Let's take a look at the second way that we could allow a user to like either a post or a comment. All right. So this solution is going to be a little bit more straightforward. Well, maybe it is, maybe it isn't. You tell me. So in this solution, we would still have a table of users, likes, posts, and comments. But our likes table is going to have a slightly different structure. It's now going to have a post ID column and a comment ID column. These are both true foreign key columns. So we do get some level of data consistency here. If we ever try to add a like and designate a post that does not actually exist, let's say a post with an ID of 999, Postgres would throw an error and say, hey, you can't like that, or you can't insert this row. There is no post with an ID of 999. So we do get to treat these as foreign key columns, which is fantastic. To actually figure out what a user likes, we're only going to ever have either the value inside of post ID or comment ID defined. So either or, but at least one. The ID that is actually defined indicates what type of like it is. So in this case, the first row would be a like for a post with an ID of 1. The next row would be a like for a comment with an ID of 3. And then we've got a like for a post with an ID of 2 right there. You get the idea. So this is a good solution because we can still have one single table here in the middle that allows us to associate a user with posts or comments, and we still get to use foreign key columns. So seems like a good all-around solution, right? There is one thing that we might want to add in. We might want to add in a little bit of validation to make sure that whenever we insert a row, either the post ID or the comment ID is defined. We could have a developer who writes some bad code, or we could have an administrator who's trying to manually insert records using pgadmin. So we would want to make sure that we never get in a scenario where we accidentally have both a post ID and a comment ID, or neither a post ID or a comment ID. To add in a check like that, we could use a check constraint. You might recall we spoke about check constraints a little bit ago. We were talking about validation. A check constraint allows us to add in a essentially validation check whenever we insert data into a table. So we could take a look at all the different columns of that particular row that we're trying to insert and make sure that it passes some kind of check. Now, the downside is that to write out a validation rule around this and make sure that either post ID or comment ID is defined, we end up having to write some complicated SQL. So this is pretty much what we would write to add in a check constraint on the likes table to make sure that we always have either a post ID or a comment ID. Let's kind of digest this check statement really quickly. The first thing I want to take a look at is that coalesce function. We've not spoken about coalesce before. It sounds like a really scary function, but believe me, it is extremely straightforward. Let's take a look at coalesce very quickly. So back over at pgadmin, you don't have to write this out if you don't want to. I'm just going to give you a very quick demonstration here. We can do a select coalesce, kind of hard to spell, so note the spelling there. And then I'll put in null and 5. All coalesce does is it takes a look at the different arguments it is provided, and it's going to return the first value that is not null. That's it. In this case, the first value is null, so we're not going to return it. The second value is 5, so we are going to return it. And I've got this, there we go. So we don't get null, instead we get 5. If we stick in 10 and 5, now the first value is not null, so we get back 10 instead. That is all coalesce does. It just makes sure that you get back a value that is not null if you provide an argument that is not null. So with that in mind, we can then kind of pull apart the rest of this line here. I'm going to copy just this first little bit and take it over to pgadmin. I'm going to put in select, then that entire statement, and then I'm going to replace post ID right there with, how about a 4? Now I'm going to take the value 4, I'm going to turn it into a Boolean and then an integer. So we're doing 2 conversions there in a row. We're then going to take the result of that and run a coalesce on it. So in this case, we get 1. That means that, well, we supplied a valid ID right there. 4 is valid. If I supply null, then I'm going to get back 0, which means I just put a value inside there that is null. To help you understand what's going on with the Boolean and integer stuff here really quickly, just another quick demonstration. If I put in null, colon, Boolean, that will be converted into a null value. And if I then convert that into an integer value, it stays as null. So if we provide this as the first argument to a coalesce function, the coalesce function is not going to return the result of this. But if we put in any normal number, like a normal ID, then during that first step for Boolean, it's going to be converted into a value of true. And then if we convert true into an integer, it gets turned into a value of 1 always. So long story short, the entire goal of each of these little lines right here is to just give us either a value of 1 or 0, depending upon whether or not post ID or comment ID is defined. We then take those two values, so either 0 or 1, and either 0 or 1, and add them together, and we check to make sure that the result is equal to 1. So again, long story short here, there's a lot of meaning packed into this little check right here, but it just makes sure that we provide either a post ID or a comment ID, and at least one of them. All right, apologies for the little diversion there, but I just want to mention how that validation worked. Okay, so that's pretty much it. This is method number 2 for forming up this kind of association. So it might seem like this is a real obvious and good solution, good improvement over the last one we were just looking at. The only downside here is that if you end up with wanting to relate a user to many different kinds of things, like let's say we want to allow a user to like a post, a comment, a channel, a video, a message, I don't know, who knows what else, a website. If we want to allow a user to comment many different things, that means that we would end up with many different columns inside this table. And so at a certain point in time, we might just feel like, hey, we've got 50 columns on here. It's starting to get a little bit crazy if we want to allow a user to like 50 different kinds of things. So that's really the downside to this approach, and that is where a polymorphic association might be a little bit better. Okay, so enough of this. One more pause, one more possible solution in the next video.